So lesson 9 is all about nuclear chemistry. At the end of this lesson, you're expected to be able to describe the nuclear structure in terms of protons, neutrons, and electrons, recognize the common modes of radioactive decay, identify common particles and energies involved in nuclear reactions, calculate mass defect and binding energy for nuclei, and be able to explain the difference between nuclear fission and nuclear fusion processes. So our discussion so far in the previous lessons was focused on the outer electronic structures of atoms or molecules, wherein there were changes in the arrangement of electrons only. So, diba, sa redox, sa galvanic cell, sa electrolytic cell, so we were more concerned on the electrons, the flow of electrons. So this time, we go deeper into the inner part of the atom, which is the nucleus. So we don't look at the electron anymore. So we go into the inner portion of the atom in which we can find the nucleus. So we will study the nuclear structure of the atom and tackle the changes that the protons and neutrons inside an atomic nuclei undergo. So the branch of chemistry which deals with the study of the composition of atomic nucleus, nuclear forces, nuclear reactions, and radioactive materials is called nuclear chemistry. So, muna itong studihan. So, we recall that the atom is made up of 3 subatomic particles, and these are the electrons, the protons, and the neutrons. So, this figure shows us the structure of the atom, and we can see, diba, mura na siya og naakay nucleus in the middle. And then, this is the atom. So, siya. So, you have the electrons here. And in the middle portion, naadire sa tunga, this is the nucleus where the protons and the neutrons are located. So, here, this is the nucleus. And you can find there the protons and the neutrons. And outside, we have the electrons. So each proton has one positive charge. The charge of proton is positive 1, and each nucleus is a positive charge as well, which is equal to the charge of the proton. Nga naman, because the neutron has no charge. So positively charged protons and electrically neutral neutrons are located in the nucleus. And collectively, ang tawag nilang duha together, they're called nucleons. Well, it's understood already why they're called nucleons because they're located inside the nucleus of an atom. So, because the neutron is uncharged and proton has a positive charge, so therefore, ang charge sa nucleus is just equal to the charge of the proton. Now, a neutral atom, if we're talking about an atom, a neutral atom contains the same number of protons as the negatively charged electrons. So we have already discussed this in the previous lesson, diba? Kung ma-charge na siya, it's called an ion. So it's a neutral atom. The number of protons and the number of electrons are equal. So the electric attraction of the opposite charges pulls the electrons close to the nucleus. Right? So positive or negative, there is attraction between them. Now, let's go to the nucleus. The protons and neutrons, collectively called the nucleons, are located inside the nucleus of the atom. They are packed tightly together so that the nucleus takes up only a tiny part of an atom. Its diameter is only, imagine that, it's 1 over 100,000 of the atom itself. So it is really so small. Super siya kagamay. Such that, ang i-compare ko na the analogy is that if an atom were the size of a football stadium, its nucleus would be the size of a marble. So kintahay, or kani, if this is the marble here, so imagine the football stadium is so big, it's so huge, but then the nucleus is just here in the middle. It's very tiny. Diba? Kaya it's a marble ragud siya. So, that's the size of the nucleus. But, despite taking little space, despite it being so small, the nucleus contains almost all of the mass of an atom. So, bisag gamay kayo siya, it's very massive. In fact, the mass of a proton or a neutron is about 2,000 times the mass of an electron. So, bale, if, diba, if this is the nucleus and this is the atom, and the electrons are like here outside. So, even if this is so small, it's 1 over 100,000, the size of an atom, it's really heavy. Kay bisan pag dako kay ni siyang space dire where the electrons are located, diba? Ang iyang mass is about 2,000 times sa isa ka proton or a neutron. It's 2,000 times the mass of an electron, and we can see that here from these figures here nga bugat ang proton ug ang neutron kumpara sa electron. Okay? Now, iniingon siya diri nga they are packed. It takes up only a tiny part of an atom. They are packed tightly together. That only a part of an atom. So that it takes up only a part of an atom. Why are they packed tightly together? Ang nucleons, ang protons ug ang neutrons. So there must be a force, no, that exists between the two. Okay, so there are two forces which act upon the nucleons to produce the nuclear structure, to produce the nucleus of an atom. Okay, so first force is the electrostatic force. Electrostatic, this is the force that causes opposite electrical charges to attract each other and like charges to repel each other. So this is the force that attracts an electron and a proton. But since we're focusing on the nucleus only, diba, ang may nasa nucleus, ang proton raman ug ang neutron. So, naaray like charges inside, diba, sa nucleus. So, the positively charged protons in the nucleus of an atom have electrostatic forces acting on them, and it pushes them apart kay, diba, they repel each other man. So, kung naay proton o proton diha, so there is a repulsive force, no, that's trying to push them apart from each other, try to keep them away from each other. So, it's repulsive. Okay, and then the other type of force is the nuclear force. It's actually a nuclear force, but ano diha nga strong siya. It is otherwise called is a strong force. It's the force that holds the nucleons together. And take note, it acts between any two or more nucleons and is always attractive. So kung naay repulsive force, naay attractive force between the nucleons, so the electrostatic force only exists between the charged particles, but for the nuclear force, it also works on the neutron. So, for example, here, these are protons. So, ang proton, there is an electrostatic force that pushes them apart. But at the same time, naapoy nuclear force nga mo pull them closer together. So there is a war between the electrostatic force and the nuclear force. Okay? So a proton pair therefore will experience both an electrostatic and a strong nuclear force. So at war ni silang duha. For a proton. For the neutron, so dili man charge ang neutron, so wala electrostatic force sa neutron. So neutrons will only experience the attractive strong nuclear force. And if it is between a proton and a neutron, so again, neutron is uncharged, so meaning there is only a strong nuclear force that holds them together. So again, ang kaning electrostatic force, we're focusing on the nucleus, mo work lang siya kung naay duha ka proton. Okay, so all nucleons, both protons and neutrons, attract one another by the strong nuclear force. Only protons repel one another by the electrostatic force, as I stated ganiha. Okay, despite the strong repulsive electrostatic forces among protons, despite the force that is trying to keep them apart, all nucleons remain bound and intact in the dense nucleus because of the strong nuclear force. Mudaog si nuclear force. That's why it's called strong force. Ba? However, this strong nuclear force acts only on subatomic particles that are extremely close to each other. It is strong, but there is a condition that they have to be extremely close to each other. Otherwise, dili siya mudaog. Ang mudaog si electrostatic force kung dili sila extremely close to each other. Okay? So the presence of neutrons adds an attractive force within the nucleus due to the fact that there is repulsive force among protons, but there are only attractive forces between neutrons and between protons and neutrons. So, balik ko dire. Kani si nuclear force, mo act only siya kung they are extremely close. Diba? Kung lagyo sila, like for example, duha ka proton, mudaog si electrostatic force. But what will help this strong nuclear force para mudaog siya is the addition of neutrons. Because the presence of neutrons will add an attractive force. Kay si neutron, na may nuclear force, di ba? Neutron and proton. Na may nuclear force nga nag-act between them. That pulls them closer together. So, mo add siya attractive force. So, mapildi na ni si electrostatic force kung padugangan na to si neutron, no? This means that neutrons are important to balance the electrostatic and strong nuclear forces in a nucleus. So, mo-help na siya hold sa nucleus together. So, remember, the nuclear force that makes the protons and neutrons attract each other and stay together is called a strong force because it is 100 times stronger than the electrostatic force that tries to break them apart. Again, there is a condition. However, this strong force will only work when the particles are very close to each other.